Welcome back to the Algebra 2 series, and today we're looking at three special situations with rational functions. We've seen a lot of rational functions, we've done some work graphing them, and now we're looking at some special types of graphs and special things that occur within those graphs. Notice example 1 here, it says find the ordered pair for the hole in the graph of the given function. Now that information tells us something. It tells us that if there's going to be a hole in the graph, that um, the denominator, whoa, let me be careful on this, that the denominator is going to cancel out with our numerator. So we have two ways to handle this problem. The first way to handle it would be to factor that numerator. And in knowing that it's going to cancel, we could leave that as, say, x cubed minus 4x plus x minus 2. And if you recall from previous work, that would mean factoring the x, and that would be an x squared minus 4 plus x minus 2. And you know that is a difference of squares. So x minus 2 times x plus 2 plus x minus 2 all over x minus 2. Now I'm taking my sweet old time here working through this, but I want to show you the full factorization. As we pull out that x minus 2, we're left with x from here multiplied by the x plus 2, or x squared plus 2x, and then plus, when I pull out this x minus 2, I just get a plus 1 left over, all over x minus 2. As we cancel our x minus 2's, we see that the original function then is going to reduce to a single value. In this case, r of x is equal to x squared plus 2x plus 1, or in other words, x plus 1 quantity squared. So that's the answer to the function simplified. I'll put a little sub s over here. So that's the function simplified. And of course, we know that the number 2 can go into this one. So if we substitute that in there, that we get 2 plus 1 squared, or 9. That tells us that the hole that was created by the discontinuity here at x equals 2 is at the point 2 comma 9. So that gives us our answer to the first part. And of course, there's another way to do this. Rather than doing it by trying to factor, since we know already that these are going to cancel out, we can simply take our the original problem here, take the numerator, x cubed plus 0x squared minus 3x minus 2, divided by x minus 2, and we know we should come out with no remainder. In this case, x cubed minus 2x squared. Subtract, we get 2x squared and bring down our minus 3x, etc. In this case, you get the same thing, 2x plus 1, if we continue this out. And for those of you who have handled synthetic division already, you could do this long division by synthetic division and come out with your answer even faster. Either way, it should get you to your final solution, which is that the hole is located at 2, 9. Now the next problem is a little bit different because it's asking us to find the ordered pair for the place where the graph crosses the horizontal asymptote. And not only have I shown you the formula or the function here, but I've also graphed it for you. Going through this example, the problem states to find the ordered pair for the place where the graph crosses the horizontal asymptote. And as you can see from my picture here in red, I did not find a place where the graph crossed the horizontal asymptote. Notice in my problem here that I've got a y-intercept of none because I have a vertical asymptote there at 0. I have an x-intercept of 4. This is located over here on the graph. I've got vertical asymptotes at 0 and 2. These, of course, from my denominator. I've got a horizontal asymptote y equals 1. That's because the leading coefficients are x, or the leading terms are x cubed in the top and x cubed in the denominator, so coefficients 1 and 1. And then in the bottom of my little information box, I've made a nice little chart down here showing the sign changes of my graph. Now I can say that uh, obviously from here, there's no way that this part of the graph will go through the horizontal asymptote, because if it did, it would create 2 more x-intercepts. So that's clear. However, I do have a couple other places that it could cross through. Could cross through over here, and maybe I just didn't notice it. And it could also cross through over here somewhere. So it could cross in either place or perhaps both places. So I don't know if it's going to cross through my horizontal asymptote. Now the technique here then, knowing that the horizontal asymptote is y equals 1, let's go down the page. I'm going to rewrite my function, and better yet, I might be able to just do this by dragging it down. Sure, let's do that. I'll just extend this down here. Since I know that the horizontal asymptote is y equals 1, I will set my function equal to 1 and solve for x. This gives me x squared plus 1 times x minus 4 is equal to x times x minus 2 squared. Multiplying these out completely, on the left-hand side by FOIL, I get x cubed minus 4x squared plus x minus 4. On the right-hand side, let me clarify this in the middle part here. This is an x minus 2. X minus 2 squared times x. If it's all right, I'll do that all in one step. That's going to be an x cubed minus 4x squared plus 4x. That's multiplying the x minus 2 times itself and then distributing that x into the final values. Well, I do see that I've got 2 items here and 2 items here that do match, and so they will subtract away, leaving me x minus 4 equals 4x, or negative 4 is equal to 3x. So the answer here is negative 4/3. Wow, so I did find a place where the horizontal asymptote, there it is, right there. It's at negative 4/3, comma 1. And that's the location. I guess I was a little bit off because it looks more like negative 1, 1, but it is at negative 4/3, 1. So we found that special place, and over on the right side, I've kind of made a mess of my graph now, but on the right-hand side, it looks like what was in red originally is correct. It came up through 4, 0 and did not intersect that horizontal asymptote. All right, so the answer to the original question then, find the ordered pair for the place where the graph crosses the horizontal asymptote. The answer, negative 4/3, 1. Let me finish this video out with the last problem. It says, find the ordered pair for the place where the graph of the function crosses its oblique asymptote. And very quickly you will see that, yes, this will have an oblique asymptote since the numerator is a power 3 and the denominator power 2. Well, the question, of course, is what is the oblique asymptote? And in this case, we will have to do the long division. I'll put a 0x in there, and then I'll do the long division. It looks like we've got an x cubed plus x squared plus x. As we do this division, we're looking for the second term because we know the first one is going to be an x. And this is plus 0x squared. And when I subtract straight down, I just get x squared to bring down my next term. X squared goes into x squared once. So that is our oblique asymptote. So without even graphing, I write that the oblique asymptote is y equals x plus 1. Now I don't have to do anything else other than solve the mini equation that I set up with my function and with my asymptote. And what I'm trying to figure out here is where the two intersect each other. So obviously I'm looking for the two to be at the same location. Let's go ahead and do that computation real quick. It's going to be x cubed plus x squared plus x over x squared minus 4, and I'll set that equal to x plus 1 and work it all out. That's x cubed plus x squared plus x equals x squared minus 4 times x plus 1. Let's keep this rolling here. By FOIL here, looks like another x cubed minus, plus x squared minus 4x minus 4. Had to be careful with that multiplication. I'm extremely happy to see that these first two terms cancel out, leaving me at x, negative 4x minus 4, or 5x equals negative 4. And there we go again. We found our spot, negative 4/5. Now this problem is a little trickier because once we find that, we have to take that and plug it back into the oblique asymptote, which is y equals x plus 1. So I'll take the x, which is negative 4/5, and plug it in right there. And to find the y value, negative 4/5 plus 1 is equal to positive 1/5. And so we found the x and y value. So the place where the graph crosses the oblique asymptote is the ordered pair negative 4/5, comma 1/5. I don't even know where that is on the graph. Well, I know where it is, but I don't even know what this graph looks like, but I can be assured of two things. Number one, that it has an oblique asymptote, which is y equals x plus 1. And secondly, that the graph, when it is finally graphed, will intersect its own oblique asymptote at that little point right there. And that is the tricky types of problems that we will see and have seen in some of our rational functions. Hope you enjoyed this short video.